Whoops. Okay, so what we've done here, how we have made this code a little, or how have we made this code a little bit better? Well, now if I want to change my function here, let's say if I want to do the derivative of just x squared plus 1, okay, then I just change that and I run this code again, and I'm going to get the derivative value. I'm going to get the derivative of this function evaluated to the point 0. But there's two. I was going to say two, but maybe there's more kind of drawbacks here. One is I'm going, like, let's say I have this code. I have this great code that I've used, that I've written, um, this derivative process, this derivative computation code that I have here. Well, what if I want to use it in another part of the program? What if I want to use it 5 cells below or something like that? I'm going to have to copy and paste this entire code again down below somewhere. And like I said in last week's videos, once you see yourself copying and pasting stuff, or once you can imagine yourself that you might be copying and pasting, that is reusing code you've already written, there's probably a better way to do that. And so that's what I want to talk about here. So I want to have a function. It's gonna take in a. So I want to have a Python function called deriv. It's going to take in the function that you want to take the derivative of. It's going to take the point at which you want to take the derivative, and it's going to put. Sorry, I'm like zoned out partially, and it's going to take a tolerance, like the tolerance up here. Okay, and so that way, some applications you might want a really tight tolerance, some applications it might not be a big tolerance, and this sort of thing. And so this gives us the opportunity to specify the tolerance. So a good habit to get into for something like this, well, there's two good habits. One good habit is to give your functions, or give the parameters fun, a, and tol. We gave those names that actually mean something. So fun, we know that means function. A, typically that's denoting the place in which we're taking the derivative. And then tol, that means tolerance. But we can say with these what the function does and what each of the parameters do. So this finds the derivative of function evaluated at a using, and so notice up here we did the right hand sums because we're doing f of x plus h, or f of a plus h where a is positive. So in other words, we're doing f of a plus h minus f of a. So this is f of a, this is f of a plus h. So that's one thing we might want to say. So using right hand definition. Okay, I think I'm having a hard time spelling def. Oh boy, this is embarrassing. I somehow have just forgotten how to spell definition. That's probably close. Okay, so using the right-hand definition, so think about like taking the derivative of the absolute value of x when x is equal to 0. In this definition, this would say that the derivative is equal to 1. If you did the left-hand limit, it would be equal to 0. Minus 1. If you do the central difference, like on your homework, the answer should be 0. Now, if we wanted to have a more robust program, we would do the right-hand limit, the left-hand limit, and then perhaps, only return if those two are equal. We would return that. If they're not equal, maybe we would turn infinity or some other error message denoting that there was a problem. Okay, but we'll just forget about that for now. Maybe we can talk about that for the project. Okay, now what we're going to do is we're going to use our code up here. I'm not just going to copy and paste it because I think that could introduce errors. But let's just think through this. So I've got fun, a, and tol. What variables do I need to work with here? Well, a is going to be given, so I don't need to write a equals anything. But I can write h equals 0.5. That's okay because h is not passed in. H is only used by the function. See, fun, a, and tol, those come from outside of the function, but this h only the function needs to know about h. Delta, I need to introduce that. That's going to be the difference between successive approximations. So we'll say delta is equal to 2. And then the difference quotient is going to be, you know what, I didn't divide this by h. Okay, so the difference quotient, difference quotient is going to be the function that was passed, a plus h minus f of a divided by h. Okay, and now we're just going to have this while statement, but notice everything is going to be, so one thing that I didn't mention explicitly, when we have the function, everything is going to be one indent past it here. Have to do that. If you have something like this, Python is going to have a problem with it. If I try to run this code, there's going to be a problem right here on line 4. See, indentation error, because it's expecting at least one indented, one line of indented code there. Okay, so now we've got while delta is greater than tall. This is basically going to be exactly what we have up there. H is equal to 0.5 times h, so we're going to have h, and the updated difference quotient is going to be the function evaluated at the point a plus h minus the function evaluated at a divided by h, and then we're going to say delta is equal to np. Actually, we can just use absolute value because Python has a built-in function called absolute value, and that's what I want to use for this one. dqu minus dq, and then okay. So now I'm and then so dq. This is the derivative, so I'm going to put return dq. Okay, so I'm just going to run this code, and nothing's going to happen. It's just going to sort of save this code inside its own memory. Okay, so the fact that it compiled tells us that we don't have any obvious errors, though there could definitely be errors in the code here. Okay, so now I have this function up here, x squared plus 1. So I'm actually going to, just get rid of this for now. Now let's say I want to know what the derivative of sine is. I want to know what the derivative of sine is evaluated at x is equal to 0. So it should be equal to 0. So I'm going to introduce a new function. Or no, let's do something more complicated. Sorry. So let's say definition, my function is going to take in the number x, or less complicated, but you'll see what I mean. It's going to take in the number. It's going to take in the number x, and it's going to return, let's say, x cubed minus x plus 1. Okay, so now the Jupyter, my Jupyter instance running knows what this is equal to. And now I want to compute the derivative, let's say at x is equal to 2. So I know the derivative of this is 3x squared minus 1. So if I do it at 2, that would be 12 minus 1, so it should be 11. So I'm going to do print derivative. Okay, so I noticed I had a mistake up there. I did just have an F there, but that should be fun, referring to this fun here. That was a mistake. Okay, anyways, so this is my function, and now I want to compute the derivative, so I'm going to say print derivative, and now I'm actually going to pass in this function as an argument to another function. So I'm going to pass in my function, and I want to do the derivative at 2, and I'm going to make my tolerance 0.01. And so when I run this code, I should get something close to 11. Okay, and I do, pretty close to 11 there. And my tolerance is 0.01, and this is within my tolerance. So if I make the tolerance even stronger and run the code, I get something even closer, and you can see what would happen as you make the tolerance even. If you make the you can see what would happen as you make the tolerance tighter and tighter. Okay, so this is an example, another example of a function, and it's interesting because it takes a function as its argument. It takes another function as its argument. Now, let's say we wanted to do something weird. Instead of passing in the definition of a function, let's just say we passed in the number 8, and let's see what's going to happen here. Okay, so let's think through what's going to happen. When this function is called, it goes to this block of code. So it's going to run down here, and it's going to do 8, and then of a plus h. But 8 is not a function, so we should get some sort of error message here. Okay, and we do. Int object is not callable, meaning we can't call it. It's not a function, we can't call it. So when we do something like my function is x, we're calling the function, meaning we're asking Python to do whatever myfun does. When we do this deriv thing, we're asking Python to call, we're calling the function, meaning we're asking Python to run the code that's under the deriv function here. Okay, but we put in 8. Once we try to run this code, it's going to say 8 of a plus h, but 8 is not a function. It's not callable. It's an integer. So this doesn't make any sense as far as Python is concerned. On the other hand, so now we'll get back to the sine example. On the other hand, the sine function exists, for example, in Python. So let's say I want to do the derivative of sine at the point 2. I'm going to run this code, and I get this is the derivative. Okay, let's try it at 0. I know what the derivative should be there. So I'm going to run the code, 0.99999. Oh, the derivative of sine, wait. Yes, sorry. The derivative of sine is cosine. Cosine of 0 is 1, so this is correct. Or, you know, so on and so forth. If I do cosine here, I should get 0. Okay, I get, you know, minus 0, so to speak, because the derivative of sine is cosine. That's probably why it's negative there. Anyways, I mean, notice it's times 10 to the minus 0.06, so it's practically 0. The minus 0 is a joke. Okay, and we can see how this goes. I could do the exponential function. Okay, this should give us a result. So now notice it's so when I did the sine function, it's not doing it's passing in a sine function to deriv up here. So now it's going to pass in the exponential function at 0. I should get 1. I do. If I do 1, I should get if I do 1, I should get e. I do. Okay, and so on and so forth. I think you can see how this will go. And then for the homework, you'll look at other ways to write functions. Okay, so that's it for this video. In the next video, which is going to be the last one today, because it is Labor Day and I want to take some amount of time off. In the next video, I'm going to look at making classes and how we can make a class in Python and what a class is and why would we want to do a class and all of that other stuff.